Okay, so yesterday we talked about functions discontinuities. We talked about increasing, decreasing, intervals of increasing, decreasing. So today we're going to finish our topic of functions and their characteristics by looking at functions that are bounded and maximums and minimums. Oops. So let's talk about bounded. I also want to spend a little bit of time on finding domains by not looking at a graph. Okay, but let's talk about bounded functions first of all. So I'm just going to draw one here. So there's our simple quadratic. We'll say it's a 2. Okay, we would say that this quadratic is bounded below because this function does not go lower than right here. Okay, so it stops at 2, bounces back up. So we would say that it's bounded below. It doesn't go below a certain point. Okay. Let's say we had one like this. Okay, in this case, we'd say it's bounded above because this is the highest point. Okay, it doesn't go higher than that. It's going down afterwards. So we would say this one's bounded above. All right, so we have bounded below and we have bounded above. Along with functions being bounded, we can talk about maximums and minimums. So maximum and minimums come in two types. All right, first of all, we have what we call a relative max or min and an absolute max or min. So let's pick a function out and let's take a look at them. All right. So let's say we're going to graph something like this. We did something like this yesterday. Okay. So let's take a look at graph this. Now I have Desmos pulled up, so you should have it pulled up. We may have to pause to get it pulled up. All right, so let's type this in. Y equals, let's see what I got, 0.2 I think it was. Yeah. Parentheses x plus 4, parentheses, x minus 3, 3, okay, parentheses, x minus 1 I think I had. There it is. All right. So, first of all, we have a point right there, okay, and that's a maximum. But since there's a maximum that continues to go and go and go and go and go and go and go. We call this a relative maximum. Okay, so that's a relative maximum. Just like that's a relative minimum. Now, when you're talking about maxes and mins, you should write down the whole point. Okay, so for this one, we have a relative maximum. And let's see, that is at -2 and 6. Approximately, anyway. Okay, then we have a relative minimum, 2 and -1. 2, I think it was. So, those are our relative mins and maxes. All right, so that one doesn't have an absolute. Okay, so let's try one that does. So I'm going to give you one here in a second that will have one. Okay, so here we go. Let's try this one. F of x equals, okay, 0.3x to the 4th plus 0.9x to the 3rd minus 4.5x squared minus 5.7x plus 9. Okay, so we're going to type that in. And let's see, just about got it here. We have to make sure that you tap that down. Don't do what I'm doing. There we go. Oh, I got 2 equals over here. There. So there's our function right there. Okay. So this one I'm going to adjust so I get a good viewing window. I want to make sure that I have a good viewing window so I can see everything. Okay. Pretty good there. It'd be nice if it was just a little bit wider this way and a little bit smaller this way. There, I like that one quite a bit better. Okay. So there's our nice viewing window we have for this thing. We can get a pretty good view of it. All right, so down here, okay, we have a minimum. Now in this case, this is an absolute minimum because that's the lowest that that function actually goes, right? Because it goes up and up, so it's increasing. So here we have an absolute minimum. And that was at 3.87 and -21, so -3.8, -21. Give myself a little bit of room here. Okay. So that's my absolute min. Now here, we would just have a relative min. (2.1) and -8.7. Okay, if we go back to the graph again, here we have a relative max because again that function is increasing, so in both sides there, so then we would say that is a. So we would say this function has a relative maximum. Okay, so I'm going to write that down. And let's see, that was at negative 0.5 and 10.6. Okay, there we go. So, absolute, again, it has to be no lower or no more if it's maximum. Relatives would just be these next points, okay? These are sometimes called critical points, okay, because it's where the function is changing from decreasing to increasing or increasing to decreasing, okay? It has a change, so we call that a critical point sometimes, all right? Okay, so we've done all the maxes and mins that we're going to do. We've talked about boundedness. Now, a couple people asked yesterday about finding domains by looking at algebraically. So let's take a function and look at that. Just going to do a simple little square root here. Okay. Now, if I graph this, okay, it's going to look like that. Well, this is going to be negative 4. So the domain of this is x is greater than negative 4. Could I tell that by just looking at this? Well, yes, I could, because I know this. I can't take the square root of a negative number. So if I put anything less than negative 4 in there, that's what I'm going to get. So x has to be greater than or equal to negative 4. All right, so you're basically looking at the function and saying, when will the function not work? At what values will it not work? Okay, so there's an idea. Let's say we have something like this. Okay, here I know the domain's not going to work when x is negative 2y, because negative 2 gives me a 0 down there. I can't have a 0 in the bottom of a fraction. All right, so those are just some of the basic things we can look at. Let's see, I was trying to think if there was anything else. Okay, here, anything bigger than negative 2 or bigger than 2, that's okay. All right, because we have 3 squared, I can have 4 squared, I can have that, that's okay. But boy, if I put in anything less, like a 1, doesn't work, right? So then if I graph this, it's going to kind of look like this. It's going to come like this and come like this. All right, so I can have x squared minus 4 for values of negative 2. That gives me 0. That's okay. And negative 3 and negative 4 and negative 5 are okay. And 2 here, 3, 4, 5 are okay. But that's it. So then x, the domain of this, we would say is negative infinity to 2, negative, parentheses, or 2 to positive infinity. Okay? And we should really put brackets around those. There we go. So it'd be something like that. All right. So the most of those functions that you're looking at in those algebra forms, you should be able to pick out, the things where the functions, the values where the functions just aren't going to work. All right. So, okay, so yesterday I gave you some problems to work on. I just want you to add on to those today. All right, so let's add on. So we're going to go page, let's see, 102. All right, we did 5 through 15. So now we're going to add on to this. I want you to do 18 through 48 even here. All right, and I think we'll be pretty good to do those. If not, then you can ask me on Thursday, and we can help you with the rest of them if you have any questions on stuff. Okay, but work through those for now, and then Thursday, I can answer questions for you. All right, so we'll see you then.